Good morning all of you. I am Tanushri Dalai from Civil Engineering branch. So in the last class we solved a numerical based on welding connection, which is a case of butt welding case in which we solved a problem regarding V butt weld. And there is two cases. One is single V butt weld, how to calculate the strength of the weld, and in case of double V butt weld, how to calculate the strength of weld. So according to that, we solve a numerical. And now for today class, we solve the last case, which is the case of allowable stress. That means whenever in the question allowable stress is given, then how you will calculate the strength of the weld in that case. This is the case of allowable stress. Okay. So according to your types of stresses given in a welding connection, your permissible stress, or you can say the allowable stress, is different. So here is a table in which you can see various types of allowable stress or maximum permissible stress in Newton per mm square according to the types of the stresses. Okay. So the first case is, in case of tension on section through throat or butt weld or throat of butt weld, the maximum permissible stress is given as 142. These all are calculated value and experimental value, which is already present in the code book. Then for the compression on section through throat of butt weld, the maximum permissible stress is given as 142 Newton per mm square. Then third one is fiber stresses in bending, that is due to tension or that may be due to compression. The value of maximum permissible value is Newton per mm square, which is 157.5 Newton per mm square. Then fourth one is your shear on section through throat of butt and fillet weld, which is 110 Newton per mm square. Then last one is your plug weld, which value is 110 Newton per mm square. So now we solve a problem so that you can easily understand about this case 3. So here is a problem which is, in a truss girder of a bridge, a tie as shown in the figure is connected to the gusset plate by fillet welding. Determine the strength of weld. The size of the weld in the fillet is 6 mm and allowable stress in weld in tension is given as 110 Newton per mm square. Okay. So in the question you can see what are the data given. So here the size of the weld is given as 6 mm and allowable stress in weld in tension is given, which is 110 Newton per mm square. So this is the case of shear on section through throat of butt and fillet weld, so which is given as 110 Newton per mm square. Okay. So here fillet kind of welding is here. So now we have a value of size of the weld, which is 6 mm, and you can see in this figure also given in the question. So this bigger one is a gusset plate, okay, to which this rectangular plate is connected with the help of welding connection, which is a fillet welding condition. So here you can see the welding is provided on the side and at the end of the edge. That means at the three sides of the plate it is given as welding connection. What kind of welding? It is a type of fillet welding. So the total effective length of the weld should be the two sides of the welding, that means this 200 mm plus those 200 mm with the vertical welding side. Okay, we have to sum all the three sides of the welding to find out the value of effective fillet weld. Okay, so the total value of effective length of the weld should be 200 into 200 plus 200 equal to 600 mm. Okay, so we have to sum all these three sides of the welding part. Okay, so here throat thickness is not given, so we have to assume that we know the value of throat thickness, that is TE. In case of fillet weld, we have to provide throat thickness, that is TE equal to K into S, where K is a constant which you can find out the table number 22 in the code book, and S is the size of weld which is already given in the question. So the effective throat thickness for this kind of welding is K into S, where K is 0.7 and S is given as 6. So by multiplying these two values, we got the value 4.2 mm. Okay. Then the strength of the fillet weld is given as, which is the formula is LW into TE into allowable stress or maximum permissible stress divided by 1000. So here 4.2 is the effective throat thickness, which is TE, and 600 is the effective length of the fillet weld, which is 600, and 110 is the allowable stress or maximum permissible stress for this welding section, divided by 1000. By calculating all these values, we can find out the value 277.2 kilonewton, which is the strength of the fillet weld. So in this way, you have to calculate the strength of the weld in case of welding connection. So here your welding connection numericals are finished. So today this much. Thank you.